A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c equals 0, where the a, b, and c are constants and a is not 0. However, to simplify things for this lesson, we will only consider quadratic equations in which the b is 0. That is, we will only consider equations that can be written in the form of ax squared plus c equals 0, or at least in the generalized form of ax squared plus c equals 0. First, let's talk about what the effect does the a and the c have on the graph of these quadratic equations. So the graph of y equals ax squared for positive values is going to be a parabola that opens upwards, where the vertex is at 0, 0, and the vertical line, the y-axis, x equals 0, is the axis of symmetry, which means to the left of the y-axis is going to be a mirror image to the right of the y-axis. As a gets larger, the parabola is going to narrow. Likewise, if a is negative, it's going to be a parabola opening downwards, again with vertex 0, 0 and symmetry x equals 0. As a gets larger, the parabola is also, at least on the negative side, the parabola is also going to narrow. So, for example, here's a graph of y equals x squared. If I make the a part, so here's y equals ax squared, I make the a larger, you can see that the graph is going more and more narrow. As I decrease it, the parabola is opening upward, until I finally get to a point where if the a is 0, you see we have a horizontal line. That's why we exclude a equals 0. It's not a parabola. It's not a quadratic equation. But for negative values of a, it's opening downwards. And as I make it more and more negative, the parabola is also getting narrow. So here's from a equals negative 4 to a equals positive 4. Now what about the value of c? So if I increase the value of c, you can see the parabola moves upwards. As I decrease the value of c, the parabola is basically moving downwards. So the value of c affects how high up or down it goes. Notice that when I'm down here, when I'm using negative c values, this graph crosses the x-axis in two places. Right at 0, it's only touching the x-axis in one place, right there, at 0, 0. And if I have positive values of c, you can see that the graph does not cross the x-axis at all. So, again, changing the value of c in the equation, y equals ax squared plus c, shifts the graph up or down. And here's 6 parabolas or 7, where c is being chosen as negative 3 all the way up to positive 3. And again, notice that depending on the graph, some graphs cross in two places, the x-axis. So like the outside parabola crosses the x-axis in 2 places. One graph crosses in 1 place. That's where the c is 0. And there are also graphs like this innermost parabola that don't touch the x-axis at all. That corresponds to solving quadratic equations where there could be 0, 1, or 2 answers. So solutions to the quadratic equation ax squared plus c equals 0 correspond to the x-intercepts of y equals ax squared plus c. So for example, the graph you see on the screen is for y equals 2x squared minus 2. So the solutions to the equation 2x squared minus 2 equals 0 are going to be the x-intercepts, which are at negative 1 and x equals positive 1. Well, let's solve the equation x squared equals 49 by graphing y equals x squared minus 49 and locating the x-intercepts. Well, the graph's already shown, but we want the x-intercepts, which you see are at negative 7 and positive 7. So the solutions are going to be in the form of x equals negative 7 and x equals positive 7.